So this podcast has all to do with measurements. And measurements is how scientists collect data. So measuring and measuring properly is key to getting good data, getting good results, and everything like that. So measurements, the key thing to remember is whenever we measure things, or even when a machine measures something, whenever you put something on a electronic balance, and it gives you a mass of 3.45 grams, that machine knows certain numbers to a high degree of accuracy, and the last number it tells you it's unsure of. So it kind of fluctuates up and down, and that's completely fine because the machine is saying, well, it's 3.55, that's 3.56, 3.55, and that's fine. We will do that as well as humans, just like the machine will. Okay, and that's what's expected of us when we take measurements. So measurements, the best way I can do, or just kind of the easiest thing to remember is read between the lines. And if you read between the lines, measurements become super easy. So read between the lines. Alright, what I'm going to do is I'm going to pull out a couple measuring things, kind of real quick. So, let me pull out, first off, we have a ruler. Alright, and this ruler has a line underneath it. So what I might have somebody do, if we're in class, but we don't, is I just want you to tell me how long this line is. We have a black line underneath it. How long is that line? So a couple things about measurements. Measurements always have a number, and they always are followed by a unit. One of the few things that doesn't have a unit is pH. pH, we just say it has a pH of 4. We don't say 4 centimeters, it's just 4. So certain things in science are unitless, but almost everything has a unit. Okay, and units are going to be very important this unit, because if it doesn't have a unit, you're going to get points taken off. All right. So again, my question remains: how long is this line? So you might kind of eyeball it. Well, it's definitely more than 2, and it's definitely less than 3. All right. So we can definitely write a 2 for sure. Then we're going to put a decimal. And when I say read between the lines, you're going to make one estimated placeholder value. Alright? So we know the ones place, but we don't know the tens place. Alright? So we know the ones place, so we can be sure of that, but we're going to estimate the next one. So I might say, well, I think that's 2.7 centimeters. You might look at the same line and say, oh, that's definitely not 2.7, that's 2.8 centimeters. And someone else might say, you know, I think it's 2.6 centimeters. And all three of these answers are equally correct. Okay, they're all greater than 2. They're all less than 3. It's obviously not 2.2 because it's past half. So all these numbers are equally valid. We all agree on the 2 spot. We've all estimated the tenths place. All right. So we've read between the lines and made an estimation. The next thing I'm going to pull up is another ruler. And this one is a little bit different in that it is measuring not just centimeters, it's still a centimeter, it's a centimeter ruler, I guess. Centimeters is still the same length, but it actually has millimeters on it, okay? So in this case, same question, but how long is this line? Alright, so on this one, well, let's see, it's definitely more than 5. But we can even go better than that. We can say it's definitely bigger than 5.4, less than 5.5. So I might say, well, no, I think that's 5.46 centimeters. Okay? And someone else might say, no, it's probably 5.47 centimeters. And those are pretty small lines. I'm not even sure it's quite half. So someone else might say, you know, that's 5.45 centimeters. So again, all three of these are equally valid. We've agreed on the ones place. It's definitely bigger than 5, definitely less than 6 centimeters. But because we have millimeter markings, we can say, well, you know, that's bigger than 5.4 and less than 5.5. So again, we're reading between the lines and estimating one place. All right? So simply, if we just look at this, we know the ones place for sure. All right? So we can estimate the tens place. Down here, based on this ruler, we know the ones place for sure, because it has lines. We even know the tenths place for sure, so we can estimate the hundredths place. Alright? So just by looking at a piece of equipment, you should be able to tell me how far you can estimate, okay, or where your measurement should take you. So we can measure stuff lengthwise. We can also, and you'll need to do this, we can also get volume measurements. Alright, so I have a couple examples. And for example, on this one, I'm just going to bring both these out at the same time. Alright, and we are going to get volumes of each of these. So we're just going to call these, you can't see it on here, but let's say these measurements are milliliters on both of these. But this first one, what is the volume of this? Well, when we read milliliters, we always read the bottom of the meniscus. So we're really reading right there. So again, it's bigger than 20, less than 30, and I think it's going to be 27 milliliters. Someone else might say, you know, I think that's a little bit higher, that's probably 28 milliliters. And those both seem reasonable, okay? Again, if we look at what we know the tens place for sure. Alright, here's our decimal. So we're going to estimate the ones place, just like we did above, okay? So there is uncertainty in the ones place, but we know the tens place for sure. As we look at this one, here's our meniscus down here again. And I might say, well, let's see. That is definitely 5 point, looks like it's above 2, but less than 3, so I might say 5.25 milliliters. Okay, someone else might say, no, that's definitely more than half, 5.26 milliliters. So this one, if we look at our markings, we know the tens, or we know the ones place for sure. We actually know the tenths place for sure. So we're going to estimate to the hundredths place. Alright? So again, your device tells you where you can round. And you're always reading between the lines. You're going to always estimate one number. And when I say estimate one number, I mean estimate one place, one placeholder. And that is how you take measurements in science.